Hello dear students, in this video we are going to see about LL1 parsing. What is this LL1 parsing? It is a top-down parser, which means we are going to start from the start symbol and we are going to derive the inputs. And we have another type of parser, that is bottom-up parser, which means we are going to start from the input. For example, it is like ID plus ID into ID, and then we are going to reduce it and finally we bring the start symbol. So it is called bottom-up parser. So this LEL1 parser is a top-down parser. This LEL1 parser is under top-down parser. It has two types. One is recursive descendant parser. Other one is non-recursive predictive parser. So this LEL1 parser is also called as predictive parser. Why it is predictive parser means for a given input and for a non-terminal, which production to be used is already defined in the parsing table. So it is already predicted. So it doesn't need any backtracking. So that is why it is called as predictive parser. And this recursive descendant parser means it is not a predictive parser. So it will take a production. If it is not suitable, then it will backtrack and go to the next production. So it is not an efficient one. And so these are the two types. So in this class, we are going to discuss about this predictive parser, also called as LL1 parser. And in the bottom of parser, we have shift reduce parser and LR parsers. So that we will be discussing in other videos. So generally, we know what is the purpose of a parsing. And there are two types of parsing also we discussed. And now what is LL1 parsing means? L stands for left to right and the next L stands for leftmost derivation. And one says that we are going to take one symbol at a time. That is, we are going to look at only one symbol to apply the rules. So that is what LL1 parsing means. And this is very simple, and there is no guessing because we are going to predict which production to be used for a given input symbol, and there is no need of backtracking. So, what are the requirements for this LL1 parser? Means we know that the context-free grammar is our context-free grammar is going to say the rules of the programming language. So, this is very in base of this parsing, no? So this context-free grammar, which you're going to use for this LL1 parser, should be free from left recursion and left factoring. So what is left recursion, left factoring? So all the basic things of parsing is already discussed in the previous video. So I recommend you to please listen to the previous videos and then come to this. So it will be easy for you. So these are the important qualities for the CFG context-free grammar to be used in this LL1 parser. And this LL1 parser is efficient, as I told you, because it is predictive, because it for a given input, it knows which production to be used, and also no backtracking. Since it is already predicted, it doesn't need any backtracking. And it is going to use a parsing table for the fast decision. So how to make all this parsing table now we are going to discuss here. So what are the components of this LL1 parser is? First one is it has parsing table. So this parsing table only have the details about for a non-terminal for a given input symbol which production to be used. This detail is there in the parsing table. So this is the algorithm LL1 parser. It has a parsing table. Also it has a stack. The purpose of the stack is it keep track of all the grammar symbols starting from the start symbol. Further, it will be expanded. And so all these things will be maintained in the stack. And then we have an input buffer, which is going to maintain the input symbols. For example, if you want to check whether this input symbol is derived from this context-free grammar or not, that is the call as parsing, right? So that input symbol will be kept in this input buffer. And finally, after doing the parsing, we can say whether it is parsed successfully or it does it have any error or not. So here I have a context-free grammar which is free from left recursion. This left recursion is eliminated. After eliminating the left recursion, this grammar is there. And now we have an input symbol string as well. We have to check whether this input string can be derived from this grammar or not. So the first thing is we have to check whether this grammar is free from, it should be free from left recursion. Also, it should be free from left factoring. So how to this both is already discussed. So please watch those videos which is given in the description as well. And now the algorithm to do this LEL1 parser is, as I told you, we are going to use some components. So the first component we have already discussed is stack. So the bottom of the stack will be first inserted with dollar. So we know that we reached the end of the stack. And then until the stack is empty, we have to do some certain step. One is, if the top of the stack is a terminal, for example, in the top of the stack, you have a terminal. So usually terminal will be in the form of small letters. So if this is matched with the input symbol, for example, in the input also we have A. If this both are matching, then you have to do the operation of pop. That is what here. And after you pop, you have to advance to the next input. And if the top of the stack is a non-terminal, for example, instead of A, if it has a non-terminal, let us be T. So usually non-terminal will be in the form of uppercase. So if it is a non-terminal, then what you have to do, you have to go and see the parsing table. So the parsing table will be having all the details for a given non-terminal, for a given input symbol, which production to be used will be defined here. So we have to replace this non-terminal, or we have to expand this non-terminal with the right side of the production given here. So these are the two things. If it is a terminal, pop, and if it is matching to the input, pop it out. Otherwise, if it is a non-terminal, then go and check the parsing table and replace this or expand this non-terminal with the right RHS, which means right-hand side of the production. If, for example, if there is no rules in this place, then it is wrong. So there is a syntactical error. So then we can report. So these steps will be repeated again and again until you are reaching the bottom of the stack. That is, here it should be dollar. Also, you should reach in the input stack also at the end we have a dollar, which says we reach the end of the buffer. Here also we have a stack which says we reach the end. So if we are have dollar at the end in the both the places, then we can say the given input string is acceptable. So now, as I told you, this grammar is free from left recursion and left factoring. So after it is free from left recursion and left factoring, now we have to find the two functions, first and follow. So what does first means? For example, if I am in this row, we want to find the first of E. What is first of E? Whenever I expand this E with this production E, TE dash, who will be the first symbol? That is what first. So who is in the first of E? T is there. Since T is a non-terminal, further you have to expand it. What is for T? T is FT dash. How will you know? See, you know for T can be expanded as FT dash. And if you see the first symbol, again F is a non-terminal. Further you have to expand it. And if you go and see in F, F can be derived as ID, and also F can be derived or expanded as this production. So if I replace F with ID, so who is in the first of E? First of E is now ID. So first of E is 1 is ID. The same way, if F is now replaced with the next production, that is this open parenthesis E and close parenthesis, which is given here, then alternative production of F. If you see in this case, who is in the first? The first is open parenthesis. So here, one is ID, other one is open parenthesis. So that's it. So this is the first of this E. So whenever I derive E, expanding, who will be the first symbol? That is first. Now let us come to the next production. Who is in the first of E dash? So if I take the E dash production and when I expand it, who will be the first symbol located as? For example, let me take E dash and I expand it. E dash can be further derived as plus T E dash. So this is what the expansion of E dash. And if you look at it, the first symbol here is plus. So plus is a terminal, right? So if it is a terminal, directly we can write plus. And now, so this is one production for E dash. What is the other production for E dash is epsilon. So this E dash can also be written as epsilon. Epsilon means what? Empty. So for this, I can also use epsilon. If epsilon is there, directly write epsilon in the first. And now come to this T production. Who is in the first of t? So when I derive t, t can be further derived as f e dash. So f can be further derived as id. That is one production. So I can write id. What is the other thing I can write here? So instead of id, I have another production for this as well. So what is it? I have open parenthesis e and close parenthesis. Who is the first of t now? That is open parenthesis. So that's it. Now look at this production t dash. Who is in the first place? Star. Star is a terminal, so we can use it star. And other production is epsilon. Epsilon means directly you can write. And if I see the first of f, whenever I derive f, who will be in the first? So one is I can use ID. So ID is a terminal. So there is nothing to worry about it. So directly I can write, for example, NFFI, F can be further derived as ID. Also, F can be further derived as open parenthesis E close parenthesis. So here it is ID, here it is open parenthesis. So from one production first is ID, from other production the first is open parenthesis. So when I derive from this, when I derive anything from this non-terminal, will be the first symbol produced by this production. That is the first. Right. Now the next one is follow. What does follow means? Who is next to me? That is follow. So, for example, all the derivation will be starting from the start symbol. And then from the start symbol, where only any other derivation can be happening. So after this and start symbol, to know the end, we will be always appending a dollar. A dollar will be sending, denoting that we have reached the end. So who will be following S is dollar, right? Who is next to S is dollar. So by default, always for the start symbol, dollar will be there. By default, blindly we can write one of the follow of start symbol is dollar. And now you have to see in E, wherever E is coming in the right hand side. So here there is no E, there no E, no E. And if you see here, here is a E. Followed by this E, who is there? Oh, close parenthesis. So who is following E? Who is next to E? That is close parenthesis. So that is also there. So for this E have two followers. One is E can be followed by a dollar or E can be followed by this close parenthesis. Since it's a terminal, no problem. Directly you can write. Now let us go to E dash. If you see in the E dash, look at here. Where are all E dash is present in the right hand side of the production. So here we have E dash. Who is in the right side of the E dash? Nobody is there. Right? Following E dash, nobody is there. If nobody is there, then you have to do according to the rule, go and take the follow of left hand side. So what is follow of left hand side? Follow of left hand side is E. What is follow of E? In the follow of E, we have already dollar and close parenthesis. So write dollar and close parenthesis. Okay. Now you come here. Here is also E dash, followed by E dash. Nothing is there. So we have to take the left hand side's follow. E dash follow only we are finding, right? So nothing. So no other place E dash is there. So that's it. The next thing is T. Who is following T? See here. T here is in the right hand side. You have to check for the follow. Who is following T? E dash is following. And E dash is a non-terminal. So we have to find the first of E dash. What is in first of T E dash? Plus and epsilon. So what is the meaning of it? After T, when I replace E dash with some its expansion, the first symbol coming out of it's what we already found in the first. So in the place of E dash, what can come? One is plus. So if plus is there, who is the follow of T? T is followed by what plus? So plus. Another one is what is in the first of E dash? Another alternative is epsilon. What is the meaning of epsilon? Epsilon means nothing. So nothing will be there. Okay, that is what epsilon means. So now who is following T? T is followed by nothing because I have replaced E dash with epsilon. So in that case, nothing is coming means what is the rule? We have to take the left hand side follow. So what is the follow of left hand side? That is E dollar and close parenthesis. So here we have dollar and close parenthesis. Now check whether any other place we have T. Here we have a T. right? So let us look at this T. Okay, we'll correct it before that. So this T is followed by E dash. So since it is a non-terminal, we have to go and check the first of E dash. So one is plus. So plus is already there. Another one is dollar. So if I replace this place with a epsilon, so here it is epsilon. Epsilon means nothing. So if nothing is there, what is the meaning? Sorry, if nothing is there, we have to take the fall of the left hand side, that is E dash. So what is there in the E dash? Dollar and close parenthesis, that is also already there. So that is, so nowhere else T is there, so we can close it. So we can, I hope you can understand what is it. So now I'll correct it. So actually what is there? So let us write it because later words it may be required. So here it is already E dash, right? And here is also it is E dash. Right. Now let us see the fall of T dash. T dash means what you have to do? See all the RHS wherever T dash is coming. If you see here is a T dash. So after T dash, nothing is there. So what you have to do, if nothing is following this T dash means we have to take the left hand side's follow. So what is left hand side? T's follow is plus dotted close parenthesis. Anywhere else T dash is coming, here is a T dash followed by T dash, nothing is there. We have to take the follow of this T dash, then left hand side. So for this T dash only we are finding, so nothing is there. So nowhere else T dash is coming, so close it. Now F is there. Follow of F. See in the all right hand side wherever F is coming. Here is no F, here is no F, here is a F. Who is following F? T dash. T dash is a non-terminal. So we have to go and see the first of T dash. What is first of T dash? One option is star, which means what? This T dash, and I expand, the first symbol I'll be getting is star. So who is following F now? Star. So follow of F is one option is star. What is the other option for T dash epsilon? Which means what? This can also be replaced by epsilon. Epsilon means nothing. Nothing means what? After F, no symbols are there. If nothing is there, then you have to, according to the rule, go to the left-hand side and find the follow of T. What is follow of T? T contain already plus dollar and close parenthesis, right? Plus dollar and close parenthesis. Hope you got it. And also now we have to check anywhere else T dash is coming. Here is the T dash. So this T dash is also followed by nothing. So if nothing is, sorry, if F no, we have to find F. Follow of F. If follow of F only we are finding. After F you have T dash, or since it is a non-terminal, then you have to go and check the first of T dash. It is star. So so after F, star will be coming. Star is already there. Other one is epsilon. So if I put epsilon in this place, F will be followed by nothing. So then you have to go and take the left hand side follow. So T dash follow is plus dollar close parenthesis. Plus dollar close parenthesis is also already there. So nowhere else F is coming. So that's it. So this is the first and follow of this production. So how to find the first and follow with so many examples is already there in the previous videos. Kindly look at it. So after finding the first and follow, by using this first and follow, now we have to find the important step, that is parsing table. That is very important. So how to construct the parsing table is what we are going to see. Parsing table. So as we already discussed, one of the important component of LL1 parser is parsing table. How to construct the parsing table is every row contains the non-terminals. So what are the non-terminals of this grammar? We have E, E dash, T, T dash, and F. So all the left hand sides, E, E dash, T, T dash, and F. So these are the non-terminals. And in the column, you have to write all the terminals. So what are the terminals in this production? Here plus is there, and star, and then ID, open parenthesis, close parenthesis, and dollar. One more thing you have to remember, in the first you have epsilon, but in follow you will never have epsilon. Okay, that also you have to keep in mind. So here the terminals you have to write, let me write all the terminals. So the terminals of from this production you can see we have plus is there, star is there, ID is there, open parenthesis there, close parenthesis is there, and dollar is there. Now we have to fill this table. So how to fill this table is, let us draw a line so that it will be easy for us to refer later. So to fill this table, finding the function first and follow is very, very important. So that is why we found the first and follow. So how to fill it is, see here, go to e-production. Now we have to know where to write this e-production. Where to write is, check the first. So in the place of ID and in the close parenthesis, we can use this production, because if I want to derive any one of it, this production is going to help. So E derives T E dash. So where you have to put in the place of ID and open parenthesis. So in the place of ID and open parenthesis, I have to write the production. Let me write E dash derives T. Sorry, we are writing E production, right? So E production is E derives T E dash. And also here also E derives T E dash. So in the place of open parenthesis and in the ID, we have wrote it. The next is, here we have two production. One is E derived plus T E dash. Other one is epsilon. So if you use this production, who is in the first? Plus. So in the place of E derived plus, in this place I have to write E dash derives plus T E dash. And now if you see, the other production of E dash is epsilon. So if you have an epsilon, you have to go and check the follow of it. What is there in the follow? Dollar and close parenthesis. So in the place of dollar and close parenthesis, we have to write the production E dash derives epsilon. So in the place of dollar, you have to write E dash derives epsilon. What is the other one? Close parenthesis. So in the place of close parenthesis also you have to write E dash derives epsilon. We're done with that production. Now go to the third production. So where to write this production? In the place of first. First of this is ID and in the close parenthesis. So, sorry, open parenthesis. So in the place of ID and open parenthesis, I have to write T derives F T dash. So here also T derives F T dash. That is the only one production. That's it. So come to the next E dash. E dash, for this production, who is the first one? Star. So in the place of star, write the production. So T dash derives star F T dash. And then here we have an epsilon, right? So epsilon means what I said, we have to go and check the follow. So in the place of follow, we have to write follow have plus dollar close parenthesis. So in the place of plus, I have to write T dash derives epsilon. And then in dollar, T dash derives epsilon. And in the close parenthesis, T dash derives epsilon. Now go to the last production. For this production, where should I write F derives ID? What is the first of this ID? So in the place of ID, I'll write F derives ID. We have one more production, F derives open parenthesis, E close parenthesis. Where will I write? What is the first of this? Open parenthesis. So in the place of open parenthesis, I have to write F derives E. So this is called parsing table, and this is very important table. If you are making this parsing table correctly only, the input, we can check whether the string can be correctly parsed. If you make mistake in the first time follow, it will make mistake in the parsing table. If you make mistake in the parsing table, then the next thing will also go wrong. Checking parsing process will also go wrong. So this should be carefully done. It is very easy. Right? If you have any doubt, please revise it once again and check it. Now everything is done. Now, as given in the question, we have to check whether this input string plus ID into ID can be derived from this context-free grammar or not. So let us do that. So for that, parsing table is very important. So what are things are there for us? We need a stack and we need a input. We are going to keep it here. And also we are going to say what is the action we are going to do for it. Okay, so as I already told, in the bottom of the stack, we have a dollar, and always the derivation start from the starting symbol. So our starting symbol here is E. And here, what is the input? Input here is ID plus ID into ID, and always append a dollar along with that. So that will tell you that you have reached the end of the input. Okay, so this is what the starting. So we are going to check whether this input string can be derived from the parsing table or not. So now you see who is in the top of the stack. This is the top of the stack, E. What is in the input ID? So you have to see what is in the parsing table for the non-terminal E and the input ID. You look at it. E on input ID. What is the action? In production, we have a prediction already. E derives T dash. This is what we have to use. We are going to expand E with T. And now you have to understand we are using stack. So when I expand E, the first symbol is T, then only E dash. So how will you push it in the stack is in the reverse order. Then only T will be in the top of the stack. So what I'm going to do is dollar, this E can be expanded to this production. That is the meaning, right? But put it in the reverse order. So first you have to push E dash, then only T. Now only then we have T in the top of the stack. Now what is there in the input? That is ID plus ID into ID dollar. Now look at here. Who is in the top of the stack? T. And what is in the input buffer? ID. So we have to see what is the prediction already there for the non-terminal T with the input ID. T on input ID is T derives. It is like T derives F T dash. So what is the meaning? T, so we have to expand it. Expand T with F T dash. Here also we have expanded E with T dash. So dollar E dash. Now this T should be expanded with T dash F. It is the reverse order. And what is in the input? ID into ID dollar. Now if you see who is in the top of the stack, F, here ID. So F on ID, you see, F on ID is this production, F derives ID. So the action is we are going to use the production F derives ID. So we are going to expand F with ID. So now how will I expand dollar E dash T dash F should be replaced by ID. And here also what is there already? ID star ID dollar. Now look at both. This top of the stack and the input. Both are matching, right? If it is matching, then pop both. Okay, so now we are going to write again. So after popping, we have dollar E dash T dash here. And here it is plus ID star ID dollar. Now we have to see who is in the top of the stack, T dash. Here it is plus. So what is T dash on plus? T dash on plus is epsilon. So it is, you have to expand T dash with epsilon. So epsilon means nothing. So T dash should be replaced by nothing. So it is dollar E dash. So in the place of T dash, nothing. So here it is plus ID star ID dollar. Now you see who is in the top of the stack, E dash. Here it is plus. So what is E dash plus? E dash plus is this production. So I have to say E dash, expand E dash as plus T E dash. So when I expand it and push it here, E dash can be replaced by E dash T plus. So this E dash is now replaced by this production, pushed in the reverse order. So, but in the input buffer, we have this. Now look at both. If you see in the top of the stack also plus, in the input buffer, it's also plus. So you have to pop it out. So when you pop it, so what is remaining in the stack is dollar E dash T. Here you have ID star ID dollar. So now you see what is T on ID. What is T on ID? T on ID is FT dash. FT dash. So you have to expand it. So dollar E dash T should be replaced by F dash. Sorry, it is the T dash. T dash F. And here it is ID star ID dollar. And what is derive F derive ID? F derive ID is this production F ID. So I'll say F derives ID, which means F can be expanded to ID. So it is dollar E dash T dash, and this F can be replaced by ID. And here you have ID star ID dollar. Now you can see both top of the stack and the top of the input, both are ID, so both are matching. So pop it out. After popping, what is there inside here is in the stack you have dollar E dash T dash. Here you have star ID dollar. So T dash on star. What is T dash on star? You have this production T dash star F T dash. So now T dash can be expanded to star F T dash. So now we have to replace that. So this T dash can be replaced by T dash F star. That is in the reverse order of this. So now in the input buffer, we have this. Now you look at both the top of the stack and here in the input buffer, both are matching. So you have to pop it. So after pop it, we are going to write the remaining E dash T dash F. And here it is ID dollar. So now you see F derives ID. So F derives ID is F ID. So F can be expanded to ID. So what happened here? This F is now replaced by E dash T dash ID. And here it is ID dollar. Now if you see in the top of the stack is ID, here is also ID. So I have to pop it out. So now who is in the remaining of who is in the remain stack? Dollar E dash T dash, and here it is dollar. Now see T dash on dollar. T dash on the input dollar is T dash derives epsilon. So expand T dash with epsilon. So if I substitute T dash with epsilon, what will be there? So dollar E dash, here it is epsilon, and here it is dollar. And now E dash on dollar. What is E dash on dollar? E dash on dollar is E dash can be derived as epsilon. So E dash can be expanded to epsilon. So epsilon means nothing. So here it is dollar, here it is dollar. So you know that whenever we come to the stage in the stack also should be dollar and input also in dollar means then we can say according to the algorithm it is accept. What is the meaning of accept? You look at the algorithm, which means see if both input and the stack are at dollar, then and it is accept. Accept means the given input string. What is the given input string? ID plus ID into ID can be derived from this context-free grammar, which means what? There is no syntax mistake or syntactical error in this input. So this input can be derived from this given context-free grammar. This checking process, no, this is only called as parsing. So we now check this with the procedure of top-down parsing. That is, in the top-down parsing, we use the algorithm LEL1 parsing, which is also called as predictive parsing. Hope you have got it. If you have any doubt in between, please rewind it once again and look at it. God bless you, ma.